Okay, أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم Assalamu alaikum and Eid Mubarak to everyone. Today we are going to study and discuss about a very interesting and very practical topic related to the foundation engineering, which is the design of gravity retaining walls. Now in today's lecture we will study about different types of retaining walls and design of gravity retaining walls, and at the end of this lecture we will discuss the choice of backfill material for the retaining walls and the drainage systems for enhancing and increasing the seepage of the pore water pressure which is generated behind the retaining wall. So different mechanisms, different systems will be discussed at the end of our today's lecture. So starting with the different types of retaining walls. So it's a brief description here because we already discussed in detail in Geotech 2, the retaining wall chapter, but we will give an overview here as well. So we as a geotechnical engineers and foundation engineers, we construct gravity retaining walls, and these walls are exerted by the lateral pressures and forces from the backfill material. Now due to the self weight of gravity retaining walls, these lateral forces are stabilized, are retained, so that's why it's called retaining wall. In field, piling wall, or sometimes they are also known as sheet pile walls, or the temporary retaining walls, are also constructed in the field in order to enhance and speed up the construction process or to get some space to work on. So sheet piling wall are also constructed in the field. Now if you want to reduce the significant amount of mortar, for example stone masonry or concrete which is used in the gravity retaining walls, cantilever walls are constructed. Now the beauty of cantilever wall is that this portion of the backfill material, or the weight of this backfill material, is acting onto the heel of the retaining wall. So that's why it's adding to the stability of the cantilever retaining wall. Now these sheet pile walls are thin sheets, and they are unable to take or retain the significant amount of lateral earth pressures. Therefore, anchors tiebacks or braces are provided just to give an extra strength to the sheet pile walls. Now here our focus would be on the gravity retaining walls, and as we discussed, the stability of the gravity retaining walls depends mainly upon the self weight of the wall, and these are massive structures which are constructed from stones, masonry or concrete. Obviously they are uneconomical because lots of materials are used to construct these types of walls. Now, in order to reduce the cost of these retaining walls, semi gravity retaining walls are reinforced concrete retaining walls are constructed. And we can clearly see that those lateral pressures are retained by the massive structure of this gravity retaining wall. Passive pressures are also applied, but usually these are ignored in the design. Now, gabion walls are the other types of the gravity retaining walls, and these gabion walls are the cages of steel mesh, rectangular in plan, elevation. These are usually filled with cobble size or greater size of the particles. The stones are placed in here and they are put in the cage, and you usually see along the streams in villages and along the slopes you will find these types of retaining walls in Pakistan a lot, because these are much cheaper. The material is cheaper, and the steel cages are also relatively cheaper than the reinforced concrete walls. There is another type of retaining wall which is crib walls, and in crib walls these are kind of precast or open structures which are made from the precast concrete. So you can clearly see the precast concrete here. So these members can also be timber members as well, and then the granular particles are placed here just to enhance the seepage and to dissipate the excess pore water pressures which is generated in the backfill. So these are different types of gravity retaining walls. Now, if we look into the cross section of the gravity wall, so we can clearly see here that the weight would be acting downward and the lateral forces would be acting in the horizontal direction in such a way. This is the base of the retaining wall. This portion is known as the toe of the retaining wall, and this portion is known as the heel of the wall. Now, if we construct a reinforced cantilever wall, now the weight of the stem would be acting downward here, and the weight of the backfill soil would also be acting downward. So we consider this as the part of the retaining wall, and the horizontal force is applied here. Okay, these are the lateral stresses which are applied. Now, in order to enhance the sliding resistance, sometimes we also provide a shear key just to increase the sliding resistance beneath the base of the retaining wall. Now, if we assume a linear distribution beneath the retaining wall, and if we find out the vertical forces and the horizontal forces, and the resultant which is acting at a particular location, and if we also find out the eccentricity, then we can find out the maximum base pressure or the minimum base pressure, which we will discuss in today's class in very good detail. So the cross section of the gabion wall will look like this, and the crib wall, if it's inclined or if it's vertical, so it will look like in figure 6.18d. Please confirm that you can hear me.
Yes, sir.
Okay, thank you. Now, there are 4 modes of failure for rigid retaining walls. Okay. The first one is the sliding or translational failure. When lateral pressures are applied in this type of mode of failure, the retaining wall will move from point A till point P, and that distance is known as delta x. There is another mode of failure as well, which is known as the rotational or bearing capacity failure. In that case, usually the lateral stresses are too high, which overturn the retaining wall. There is another type of mode of failure as well, and that is known as the deep-seated failure. Now, in that case, if the slip plane or slip surface occurs globally here, so as a whole, this retaining wall will settle, or we can also call settlement mode of failure as well. Now, the fourth mode of failure would be the structural failure. For example, if the lateral stresses are acting onto this retaining wall, and if enough reinforcements are not provided here, what would occur? These lateral pressures will crack the intersection or the joint between the stem and the base of the retaining wall. Now, starting with the design of the retaining wall or the design of the gravity retaining walls, the first step is to find out the horizontal forces and the vertical forces which are acting on to this wall. Then we will also find out the resultant, and we need to find out the soil and water levels or the soil and water properties, the shear strength parameters. All these information a geotechnical engineer or a foundation engineer must note down, and they should find out. Now, we also need to look for any possibility for the planned and unplanned excavation, because that is important. That will determine the lateral pressures or the active pressures or the passive pressures, which we discussed in Geotech 2. Approximately 0.5 meter depth of the retaining wall is preferred. 10 kilopascal of the surcharge pressure is also recommended on the backfill. Now, in case of cantilever wall here, as we can clearly see that delta would be equal to 0. The reason behind that is we can clearly see that on the right side here is also soil, and here on the left side soil is present. So phi would not be equal to 0, but delta here, which is the wall friction, it would be equal to 0. Now, if we consider the wall friction here, at the base of the cantilever retaining wall, so that won't be equal to 0 because there is a wall friction between the retaining wall material and the soil. That was about the delta. Okay, now in order to find out the lateral earth pressure coefficient, which is Ka, now we need to find out using the Rankine's lateral earth pressure theory, and which can be found out using this equation. Now, what else? Now, if you want to find out the overturning, or no, if we want to find out the base resultant location, for example, if you want to find this location, the moment arm or the point of the location or the application of the resultant, this we can easily find out using, I would call that lever arm summation of moment divided by the vertical forces. We can find out the eccentricity as well, and we need to make sure that it won't exceed beyond b by 6, and there is a practical reason behind that which I will explain in a few slides. We need to find out the total resisting moment and total overturning or disturbing moment in order to find out the overturning stability or limit state. We can also find out the maximum base pressure if we take that sign as plus, and we can find out the minimum base pressure if you want to find out the bearing capacity limit state. Now, for sliding resistance or the sliding limit state, resistance limit state, we can use this equation, which is S equal to V tangent delta, and that is the summation of vertical forces here, that is the wall friction. Now, in order to satisfy the sliding resistance limit state, the sliding resistance must be greater than or equal to the horizontal forces which are exerted onto the retaining wall. Now, this slide shows that why it is important that the eccentricity should be less than b by 6, and that b is the width of retaining wall. Now, if it's less than b by 6, the maximum base pressure and minimum base pressure should be found out And then this maximum base pressure should be compared with the bearing capacity of the soil, which will give an estimate about the bearing capacity limit state. Location and the eccentricity information should also be noted down and should also be found out. Now, in case if E is equal to B by 6, then the maximum bearing pressure would give us the maximum value, obviously, but the minimum base pressure would be equal to 0. Now, just in case that E or the eccentricity is greater than B by 6, what would happen? The soil would be in tension, and as we all know that soil is very weak in tension, it gives some strength in compression, but it's very weak in tension, then the uplift of the base of the retaining wall will occur. So this, because this portion is in tension, so the uplift of this portion, or the heel of the wall, will be uplifted. Now we will solve this example, so please kindly note down the information. So this is the information here. We are given with the retaining wall, which is 3 meters. This is the width of the retaining wall. The thickness of the base is 0.4 meter, and the width of the backfill material, which is placed behind the retaining wall, is 1.75 meter. The thickness of the stem is equal to 0.3 meter. Delta, or the wall friction here, is equal to 0 degrees, and delta here is 27 degree, which is the wall friction between the base of the wall and the soil. Surcharge pressure is also applied, which is 10 kilopascal, and the height of the retaining wall is 5.4 meter. Unit weight of the backfill is 17 kilonewton per cubic meter. Shear strength parameters are also given. C prime is 0, phi prime is 36 degrees. And how we find out the wall friction is 75% of the internal friction angle. As a geotechnical engineer, we need to answer this question, that is the design of the retaining wall satisfactory? Now, starting the solution, so we already know from Geotech 2 that we can find out the lateral force which would be exerted onto the retaining wall, or the cantilever retaining wall, and we discussed a few minutes ago that this portion of the backfill is assumed as the part of the cantilever retaining wall. Okay. Now we need to find out the lateral force which would be exerted by this surcharge pressure and the backfill soil. So from the concept which we understood from Geotech 2, we already know that if we have the surcharge pressure and if you multiply the lateral earth pressure coefficient, this will give us the lateral pressure which is exerted onto the retaining wall. And if we multiply with the height, this will give us the lateral force which would be exerted onto the retaining wall. And this would be acting at the height or the mid height of the retaining wall. Is it clear? Please confirm,
Yes,
is it
sir.
clear? Okay, thank you. Now here is an explanation if you want to recall from the Geotech 2. So the explanation is already given here on the slide 15 of retaining wall lecture number 1 on the retaining wall. Okay, now from the soil which is present here, this will give us a triangular distribution as we go along the depth of the soil or the retaining wall. Then if you want to find out the lateral thrust which is exerted, and that lateral thrust would be acting at the 1/3 from the base. So this is the base, this is the top here, thrust. Now in order to find out the Ka using the, which is lateral pressure coefficient in active condition, so please kindly note down this equation: 1 minus sine phi prime 1 plus sine phi prime, or we can also find out square of the tangent 45 minus phi prime divided by 2, and we will come up with the Ka value of 0.26. Now we need to construct a table in order to solve this problem. I gave you a hint that how we can find out the lateral force which would be exerted onto the retaining wall from the surcharge. So please kindly give me the value of that force which we obtained from multiplying the lateral pressure coefficient from Rankine's lateral pressure theory into the surcharge into height of the wall. So I need someone to calculate this force for me, please. And as you all know, that those who are participating and contributing in the
So
discussion,
14.04.
they will be given an extra preference in the rechecking of the quizzes and assignments and the papers. Okay, that would be Ashad Zawar is saying that fourteen point.
04.
Okay, it's 14.04. And how about the lateral thrust due to the backfill soil, which we can find out using this formula of Ka gamma into H will give us the pressure, and if you multiply the height of the wall, that will give us the thrust or the force which would be exerted onto the wall.
Sir, 64.4.
64.4.
4-3.
Okay, we will take that as 4 here. Now, how about the summation of these horizontal forces? Please sum those two forces. 78.48.
78.48.
Okay. So these are the horizontal forces which are exerting onto the wall. Now we also need to find out the moment arm or the lever arm for each force that we can find out using this figure, or using this figure. So this would be the lever arm for the horizontal force number 1, and this would be the lever arm for the horizontal force number 2. So what is the total height of the wall?
5.4.
Simply divide it by 2 will give you the lever arm for the first
2.7.
horizontal force, 2.7.
2.7.
Okay, so that is 2.7 here. And how about the second one, which would be 1/3 of the height of the wall?
1.8.
This will give us 1.8 here. Now I need the moments here as well. So simply multiply the force with the lever arm will give you the moment which is occurring due to the horizontal force number 1.
37.
37.908.
37.8, I would call that. And how about the second one? Due to the backfill material, so that was due to the surcharge.
115.9.
115.9. And please kindly add these two moments as well.
153.7.
153.7 would be the moments which are occurring due to the horizontal force. Okay, so please kindly note down these two values because we are going to use for the finding the overturning, sliding resistance, stabilities, and limit states. Now we need to find out the forces or the vertical forces now. Now if you look here, we can clearly see that the weight of the stem and even the weight of the base here, and also the weight of the backfill material, would be acting downwards, or in other words we can say that these are the forces which are trying to stabilize the retaining wall. Now we find out the horizontal forces which were exerting due to the surcharge pressure and also due to the backfill material. Now we need to find out these as well. And we also need to find out the lever arm for the stem and also the lever arm for the backfill soil. and the moment arm for the base as well. So I have simplified a little bit for you people that how we can find out the forces which are exerting due to stem base of the retaining wall and the backfill soil. So what is the height of the stem, what is the width of the stem, and what is the unit weight of the concrete? We can find out the force or the vertical force which would be exerted due to the weight of the stem.
सर
Yes, please.
सर सर ये गेम यहाँ पे जो हम ले रहे हो ये आरसीसी के लिए होगा या सिर्फ कंक्रीट के लिए?
Concrete के लिए. So the only unit weight which is given in the particular problem here is the unit weight of the concrete.
ओके सर.
If you look here, so we can clearly see that the unit weight of the soil is given or the backfill material is given, and the unit weight of the concrete is given. So it seems like a gravity retaining wall where the reinforcement has not been used. Therefore, the unit weight of the steel has not been given. So the only unit weight of the concrete is given and the unit weight of the backfill material is given. So we are going to use the unit weight of the concrete for the stem. So this is the stem.
सर 35.25 आ रहा है सर.
Okay, so
5.4 minus
it is 35.2.
5.25. सर
Okay.
तो वैसे अगर हमारे पास प्रॉब्लम में गिवन ना हो कि गेम आप कंक्रीट आप ये ले ले तो ये सर तो 23.5 और 23 में तो काफी फिर फर्क आ सकता है ना. तो हम
Yes,
फिर 23
definitely.
लेंगे या 23.5.
Yes, exactly. So when in reality, so you can take both if or we can take the average of these two as well, or we can take the higher value for the factor of safety. For example, if it's 23 or if it's 23.5, so it's better to use the smaller because we are going for the stability now. So if we take the lesser value, this will increase the factor of safety of the retaining wall. Okay, now for the base of the retaining wall, the height of the base, the width of the base, and the unit weight of the concrete is given. So we need to find out the vertical force which would be exerted.
So 28.2.
28.2. And how about the height of the soil, width of the soil, and the unit weight of the soil?
One four nine, sir.
148.
Okay, that is 1 Okay, I would take that as 149. Please kindly give me the summation. Is some of the vertical forces which are exerted onto
12.5.
212.5. Please kindly note down this value as well. Now we need to find out the moment arms for the stem, base, and the backfill soil, and that we can find out from here. So what should be the lever arm for the stem, for the base of the retaining wall, and for the backfill?
So 1.1 for the stem.
1.1.
और सर बेस के लिए तो सिंपल डिवाइड बाय 2 तो 1.5.
1.5. Just to explain here, okay, I would say the lever arm for the stem would be equal to 3 is the width of the retaining wall. Now you can see that here is the backfill, so we need to find out the lever arm, or this distance which is in the middle of the stem. So we need to subtract 1.5, and we also need to subtract the half part of the stem, which is equal to this. Here it's 1.9, so we'll come up with 1.1 meter, and that distance, or the lever arm, is equal to 1.1 meter.
सर साइल के लिए
Similarly,
2.125.
okay, so for soil it would be 2.12.
125.
Okay, good. Now please kindly give me the values for the moments as well.
38.83.
38.83,
42.3.
32.3,
सर 22.3 नहीं 28. 42.3 सर.
okay, 42.3, and for
316.62.
316.2. Now we need to sum, okay, 62. Now we need to sum those moments which are occurring due to the vertical forces which are acting onto the retaining wall?
397.75.
397.75.
75.
Okay, now you need to note down this value as well, and you need to give us the summation of moments which we can find out by subtracting the moments which are occurring due to the horizontal forces. So these are the stabilizing moments. So it's kind of stabilizing moments, and these are destabilizing moments. Okay, so what will be the value of summation of moments?
तो दोनों को सम करना है.
We need to subtract
Subtraction.
244.
244, and you need to note down this value as well, because we are going to use in finding the lever arm of the base resultant. Now we are given with a retaining wall. Now here is the resultant R which is acting. So we need to find out this lever arm. So in order to find that, we need to divide the summation of movement, which was, I guess, 244. So what was the value of the vertical forces?
212.5.
To 12.5. So LR would be equal to approximately 0.92 meter. Okay, now we need to find out the eccentricity as well, and the factor of safety against overturning.
Sir, 1.14.
Okay, sorry. Let me check here. Yeah, you're right. It's 1.14.
1.148.
1.148. So this would be the lever arm here, 1.14. Now, as you remember that the B by 2 is equal to 1.5 meter. Agree? Now we need to find out the eccentricity here, and this would be E. Okay, so MV are the moments due to the vertical forces, and the moments which are occurring due to the horizontal forces will give us the factor of safety against the overturning, or we can check the overturning limit state. So MV, which was equal to 397.3, and MH are the moments due to the horizontal forces. It was equal to 153.8.
2.58.
2.58, which means when the moments due to the vertical forces are the stabilizing moments are greater than the destabilizing moments, this will give you an idea that the overturning limit state is okay or it's satisfied. Now we need to find out the eccentricity as well, and the eccentricity can be found out using this equation. For example, b by 2 minus the length of the lever arm for the resultant, and we need to also check that
0.36.
0.36. You can clearly see that 0.36 is less than 0.5. It means that we will be having P max and P minimum, and there won't be any uplift which would be occurring in this case.
So kindly repeat this again.
Now, it is recommended that the eccentricity, if you remember from the lecture here, yeah, here. Can you see here now?
Yes,
This is the case. So we will be having P maximum and P minimum, and if it is greater than the eccentricity is greater than b by 6, then this soil would be in tension condition and the uplift will occur. But as the case 1, I would say that this is the prevailing, or the uh, eccentricity is less than the b by 6, so that's why there won't be any uplift which would be occurring in our case of the retaining wall. Okay, now here, so we need to find out the P max, which is the maximum base pressure which is occurring at the toe of the wall here, assuming the linear distribution beneath the base of the wall here. So this will give us the P minimum, and this value will give us the P maximum. So this is the toe of the wall, and here is the heel of the retaining wall. So maximum bearing pressure. Use the vertical forces, width of the retaining wall, eccentricity, or the location at which the resultant is occurring from the mid portion. Use these two equations to give me the maximum base pressure and the minimum base pressure.
Sir, P maximum 120.3.
120.3. Okay, 120.3. That would be in kilopascal. How about the P minimum?
19.8.
19.8. Now, here in this problem, the bearing capacity is not given of that soil. But for example, if the bearing capacity is 130 kilopascal, if it was given, or we can also find out using the shear strength parameters and the friction angle which is given. So we can compare the bearing capacity and the base pressure. So as the bearing capacity is greater than the P maximum, which we will also solve in the next problem, then we can say that the bearing limit state, or the bearing capacity limit state, is satisfied. If the bearing capacity of the soil, if we calculate, if it's, for example, 100 kilopascal, And then if we compare here, this is greater than the bearing capacity of the soil, so it means that the bearing capacity limit state is not satisfied. I hope you understand the explanation here. So if it's given, then you can compare the maximum base pressure and the minimum base pressure. More specifically, we need to look at the maximum base pressure which is occurring at the toe, or even if the eccentricity is towards the heel of the retaining wall, then we need to look at the value towards the maximum base pressure. Okay, if it's occurring on the either side. Now we need to find out the sliding resistance limit state. So in order to find out the sliding resistance limit state, we need to use this equation, and please kindly note down this equation as well, because it's very important from exam point of view, quiz and assignment point of view. Okay, so V is the vertical force, H is the horizontal force, and delta is the wall friction, which is 27°, I guess. Please kindly give me this value as well. And if you remember, sliding resistance is equal to V tangent delta, and H is the horizontal force. If S is greater than or equal to H, it means the sliding limit state is okay or it's satisfied.
One 1.379.
1.379. That was it. So as you can see that this is the condition, so it means that this is okay. The sliding limit state is also okay. It means that this retaining wall with particular shear strength parameters and the unit weights which are given and the backfill material which is present there, and with the current dimensions, in this condition this retaining wall won't fail. Okay, so if we take all these parameters, so all the horizontal forces or the stresses which are applied here or even here or even here, this retaining wall will remain in a stable condition because the overturning limit state, the sliding limit state has been satisfied. Okay, that was relatively simpler problem. Now we are given with a bit more complicated situation where the retaining wall is inclined. If you see here, so the retaining wall, first of all, that is inclined, and that angle, if you remember from Geotech 2, which was discussed in Coulomb's lateral earth pressure theory, that is denoted by alpha, and this sloping surface or the inclined surface is denoted by beta. We need to make a correction. It's 0.70 meter. Now this distance is 0.5 meter. This distance is also, it's not to scale, so 0.5 meter. This distance is 0.7 meter. Here the width of the retaining wall is 2.75 meter. Okay, the unit weight of the wall material is given, the backfill material is given, shear strength parameters are given, and the wall friction is given. Okay, now you can clearly see that it's inclined. So this is the wall material and this is soil. So the delta, the wall friction here, if you remember the Coulomb's lateral pressure theory, and the wall friction here would definitely come into play here. So the delta here is 26 degrees and the delta here is also 26 degrees. Okay, now the allowable bearing capacity of the soil is also given, and that is 250 kilopascals. So we can also check the bearing capacity limit state here by comparing the P max, or the maximum base pressure, which would be exerted onto the base of the retaining wall. So we need to answer, is the design of the wall satisfactory? So how we are going to start solving this problem? So we can start with the information of alpha, beta, phi prime, and delta. And if you remember, I have taken this Ka, the lateral earth pressure coefficient value, from the Coulomb's lateral earth pressure theory, which we discussed in Geotech 2. If you remember here, this was the lateral thrust in active condition, and this is the equation for finding the lateral pressure coefficient using different alpha, phi, and delta and beta parameters. Now use this equation and give me the Ka, or the lateral pressure coefficient in active condition value.
Sir, 0.485.
Okay, so I would say 0.489.
85.
Okay, so let's take it as 0.48. Okay. Now we need to find out the lateral thrust, which is exerted. This PA value, the lateral thrust, which would be exerted at an angle of 36 degrees from the horizontal. This would be 36 degrees. But if we draw a normal here, so it would be 26 degrees from that normal. So the lateral thrust, or the force, Ka is equal to 0.48. Gamma is 23.5. What's the value of the height of the retaining wall? What's the value of the height of the retaining wall? It's 6
5,
meter.
6 meters.
6 meter.
सर ये गेम बैकफिल का नहीं हुआ?
203.04.
203, sir.
203. So 203 would be PA, right?
सर गेम फिल 18 है सर.
kilonewton per meter. आपका नाम क्या है जो कह रहे हैं कि 18 है? What is your name? एजाज, thank you very much. बाकी थोड़े सो रहे हैं कि क्या कर रहे हैं आप लोग? हाँ जी, हम 23 क्यों ले रहे हैं और वो 18 क्यों ले रहे हैं? This is wrong, okay? We need to take 18 here. Let me correct that. I just got 10 by 10, okay? जहाज अगर आपको कोई मसला हो क्विज और असाइनमेंट में तो मुझे आप आ जाएं कि सर मैंने एक्टिवली पार्टिसिपेट किया था क्लास में, so please kindly recheck my quiz and reconsider my quiz and assignment. So I will recheck if I have made a mistake there, so we can do that. Okay, good. Now we will use 18. So what would be the new value of the lateral pressure or the lateral thrust?
155.5.
155.5 kilonewton per meter. Okay, now once we find that, we can calculate and we can construct this table. So we need to take this is the resultant, so we will divide that resultant in the horizontal component and the vertical component, and this would be the horizontal component, and this would become the vertical component of this PA, okay, and this one was the lateral thrust or the force. So once we get the horizontal and vertical component of that PA, one thing which we need to do is this one. The second thing we need to do here is that we need to divide this retaining wall in different मैदान की वैल्यू क्या होगी?
सर हॉरिजॉन्टल के लिए 2 होगी सर.
हॉरिजॉन्टल के लिए 2 होगी. Okay, and for the vertical one
2.4.
this would be 2.4. Okay, now give me the moments as well.
Two 51.6.
251.6. Okay, so these are the only moments which are occurring due to the horizontal forces or force. So in this case, now we need to find out the moment for the PA sine 36 degrees as well.
219.38.
219.4. Okay, and how about the forces due to the four portions or the parts of the retaining wall? So one is, I have simplified it for you, half of H, B, and gamma are the unit weight of the wall. So we need to find out the forces, the moment arms, and the moments. So for one, what is H and what is B?
So H is 6.
And how about the B, width of the this portion?
1.05.
Now use this equation. Please kindly give me this value.
74.025.
74.02.
74.02. Okay. And how about the second part, H into B into gamma of the wall, which you can find out from here. So this is the second portion of the retaining wall. Width is 0.7 and height is 6 meter.
49.35.
49.35. And for the third portion of the retaining wall, let me see, this is here, so we need to subtract the height of the base. So this needs to be subtracted from the height. The total height is 6 meter. So if you subtract this one, I guess it's 0.75. Let me check. Yes, it's 0.75 meter.
30.84.
30.84. And how about the fourth one? 0.75, and I guess it's 1 meter because 0.5 meter is here and 0.5 meter is here. So the width is 1 meter and the height is 0.75 meter. So we will come up with the force.
Sir,
Yes,
Sir, you
The
said
please.
the
second number
98.8.
98.
for number 2, it's coming out to be 98.7.
98.7. Okay. Yeah, this one is the
Sorry.
correct one. This is also correct. 30.8 is also correct. Now give me the last one, please. Use the unit weight of the
17.6.
17.6.
63.
Okay, I would take that as well. Now, how about the moment arms? Now, let me draw here as well 0.7. So if the total is 2.75 meter, so this portion would be equal to 1.05. Okay. Now for the first one, if you just subtract the 2/3 of, so if you just subtract the 2/3 of 1.5,
2.05.
this will be the moment arm for the first portion. Agree? So
2.4.
let me check here. Yeah, it's right. It's 2.05. And you can calculate the moments as well. Someone can take care of the moments, and this one is kilonewton meter. Okay. So how about the second part? So it's simply this would be subtracting 1.05 plus, and if you subtract the half of the 0.7, this will give us the lever arm for the second part of the retaining wall, this part here. So what should be the value here?
1.35.
1.35.
1.35 would be that value. 1.35, and for the third part here, now if we subtract, for example, 2.75, that 1.05 plus 0.7, and now we also need to add the 1/3 from the right side, this portion, and that is equal to 0.5, I guess. So if you do that calculation, so this will give us the lever arm for the portion number 3, so this distance. Okay.
0.83.
0.83.
Excuse me. Okay, let me check here as well.
833.
0.83. Okay, good. Now it got a bit messy here, but let's see. So now for the fourth one, it's simply, if it would be in between, it would be 0.5. Yes, that's 0.5 because it would be acting at the middle of this part 4, and we can clearly see that this portion is 0.5. This portion is 0.5, and this portion is also 0.5. So it would be acting at the mid of the part 4. So the lever arm here would be 0.5. So once you do that, it's 0.83 and 0.5. I need these values as well, the moments values.
Sir, first one carry 151.74.
151.74. The
Second
second
carry
one,
133.245.
4.5, I would say 2.5. Or the third,
25.6.
5.6. Okay.
8.8.
Okay. Now please kindly sum those values. These one, okay, because these will give us the moments due to the vertical forces acting onto the retaining wall.
538.79.
Okay, that would be 538.79.
0.79.
Okay, now we need to subtract the 251.6 to get the summation of moments, because these are the
287.
moments, destabilizing moments. Okay, these are stabilizing moments. These are destabilizing moments. 280.
287.19.
Please kindly note down this one. Okay, this value, this value, this one, and we need to sum this these vertical forces as well, along with this one. So this, once we add these values, it will give us 312.5 kilonewton per meter, and note down this value as well. And what we need to do next after this, so we can find out the lever arm for the resultant. And that we can do using this equation. We can also find out the eccentricity. We can compare the MV and MH to see if the overturning stability limit state is satisfied or not. And if you calculate, this would be 0.92 meter. And for the eccentricity, it would be 0.455 meter. And I need this value mv divided by mh.
Two point one one.
2.14.
2.11 or 2. So mv is greater than mh. It means that the overturning limit state is okay, or it's satisfied. Okay. Now we also need to find out the p max at the toe and p minimum at the heel, which we can find using this equation.
So 225.2 Pmax.
So we find out the lever arm for the resultant. Can you hear me now?
Yes, sir. Screen share.
Okay. So once we construct a table, we come up with the lever for the resultant, and we'll compare the moments due to the vertical load moments. The load stabilizing moments are greater than the destabilizing moments. It means the turning limit is okay, or it's set. That of that soil, beneath the retaining wall, that's 250 kilopascal. Now you find out the maximum base pressure which is acting at the toe of the retaining wall, and the minimum base pressure which is acting at the heel of the wall. So you can use these equations to give me those two values so that we can compare the Pmax with the bearing capacity value of the sliding wall. Okay, anyways, this one
So
you can solve.
225.2.
Okay, 225.2. So this would be also kilopascal. It's I guess 1 kilopascal. So we can clearly see that the P max is less than the 250 kilopascal, which is the allowable bearing capacity. So the bearing capacity limit state is also satisfied, or it's okay. Now for the sliding resistance and the horizontal force, I guess it was 125.8 kilonewton per meter. Now how about the sliding resistance? Take delta is equal to 26 degrees.
152.42.
2.42 as S is greater than H. It means that the sliding is also okay, or it's satisfied. Now what else we need to find out? That's it. So we can compare all these three limit states. So the overturning limit state is okay, and the bearing capacity limit state is also okay. The sliding resistance, we can say sliding limit state is also okay. So the design of this retaining wall is satisfied. Okay, now that is all about those numericals and problems. There's a bit theory here which we need to discuss in order to understand the choice of the backfill material. Now, as you can see in here, the preferable material if this is the retaining wall, so the preferable material here as the backfill material is the granular material. And what could be the possible reason? You have already studied the retaining wall in Geotech 2. What could be the possible reason that we choose the granular backfill material? हम granular backfill material को क्यों choose करते हैं? Is a backfill. आवाज आ रही है कि नहीं?
ड्रेनेज प्रोवाइड करता है सर पी।
क्या?
अच्छी ड्रेनेज होती है सर।
ओके, ड्यू टू द ड्रेनेज, ठीक है, सीपेज और द डिसिपेशन
सर पोर वाटर प्रेशर जनरेट नहीं होता, वो
of excess pore water pressure, hydrostatic forces जो है ना वो कम लगती है, ठीक है, due to the dissipation of the excess pore water pressure. Now, no matter what material is used as a backfill, its drainage is of great importance. ठीक है? Yes, please. Please wait, okay, for a few minutes, and then we will take the attendance. Just for a few minutes. Okay, now usually a drainage mechanism or system should be provided, and you will see when you are going to Murray, Abbottabad, Ayubia, so you will see these kind of holes which are present in those retaining walls. And these are known as weep holes, which are provided to dissipate the excess water pressure. And on the right side, you can clearly see a retaining wall which has been failed and which has significantly affected the communication between two parts of that city. You can clearly see the height of the retaining wall compared to these cars too high. One reason could be that. The second reason which we can see here is that the material looks like the clay material, fine grained. So, and the vegetation shows that significant vegetation has been grown, which means the pore water pressure behind the retaining wall is significantly greater. And once the rainfall occurred, that retaining wall or the lateral forces and pressures were exerted onto this retaining wall, and that made it failed. So weep holes are provided. We need to also provide few gravel pockets just to avoid the clogging or the blocking of those weep holes. Granular backfill is provided. Filter materials or open jointed pipes can also be provided to enhance the seepage or the flow of the water or the excess water pressure dissipation. Filters or filter strips can also be provided. Here you can see those inclined filter strips can be provided, or the filter strip can also be provided at the heel of the retaining wall. Now, blankets can also be provided to enhance the dissipation of the excess water pressure, and they can also be inclined filter blankets just to enhance the dissipation or the drainage of that backfill material if we are using fine grained backfill material or the clay backfill material. Thank you very much for listening very patiently. Now we will move towards our question and answer session. Assalamu alaikum and Allah Hafiz.